word for you is a polyhedron, which is a three-dimensional figure, which we call a solid, that is bounded by polygons only, which means not circles. Anything that's round doesn't count. Has only polygons. The faces are the polygons that are the, quote, like sides of the polyhedra. The edges are where is the line segment. I'll just say segment. The segment formed by the intersection of two faces. And then the vertex is a point where three or more edges meet. So there's not just one of these on each solid, there's obviously more than one. But if you look at that picture to the right, you see several. Okay, on this polyhedra, there are 1, 2, 3, 4, 5, 6 faces. Anything that's a flat polygon counts. You have a bunch of different edges anywhere those faces meet, and you also have a lot of different vertexes as well. So, if it has a circle in it, it is not a polyhedra. If it has anything that's rounded or curved, not a polyhedra. Has to be made up of all flat sides. So you see the difference here in this box? On the left, you have polyhedra because everything is flat, and they're all made of polygons. On the right, you've got curves, not allowed. Okay, let's talk about the difference between these different like families of solids. This is like the last thing. We'll start with the prism. Okay, a prism is always made up of two polygon bases. And it doesn't always have to be the top and the bottom. It could be on the sides. So like here, in a rectangular prism, really it could be wherever, but two polygon bases. This is a rectangular prism. So prisms always have a base on the top and the bottom or the left and the right. They're like end caps. A pyramid does still have a base. It has one polygon base, but it does not go to another base. What does it go to? A point. So you have a point at the top and the base. So one polygon base and one point. There's circles, and some would argue, myself included, that there are other types of cylinders, like ones that are made up of ellipses for the bases and other natural shapes. But for the most part, we have circles. So I'm going to say two round bases just to include more types of cylinders. But if you want to put circles, I guess that's fine. So two round bases, end caps here and here. Cones still have a round base, but does not go to another base. What's it go to? A point. So one round base and one point. Okay. And then you have a sphere, which doesn't have any bases at all. It's just its own little thing. Cool. So we say, we name it by the base, would be the first name. And then the family, or the type of solid, is its last name. So your family name, just like you have a family name, prism, cylinder, cone, what am I forgetting? Pyramid. It's going to be one of those four. If it's a sphere, then it doesn't have a family. It's just the sphere family. I guess it does have a family. It doesn't have a first name. So this is a pentagonal prism because the base is a pentagon and it has two bases that are polygons. This is a triangular pyramid because the base is a triangle and it goes to a point. Okay, let's name these. Let's start with the bases, please. You got bases here and here, and you have some congruent markings that I need you to pay attention to. What is the base? It's a rectangle, and so you say it's a rectangular. That's like its first name, describing the base. Rectangular what? Prism. It's a tissue box. And is this a polyhedra? Is it made up of all polygons? Yep. So we are going to say, yes, it is a polyhedra. Next one. Let's name it first. What's the base? Hexagon. So yes, it is hexagonal. Weird word. And what's its family? It's a pyramid because it comes to a point. Is it a polyhedra? Is it made up of all polygons? Yes, it is. Look at the sides. You have, it's made up of triangles going around, and the base is a hexagon. All of those are polygons. Okay, and the last one. We can still name it by base and type. So the base is a circle, and it is a cone. So you can call it a circular cone. Is it a polyhedra? No. So this is called a cross section. And here are three different ones. If you slice a square parallel to the base, you get a square. Right there. If you slice it diagonally, however, you will get a rectangle. And if you slice it going to a vertex, it's going to be a triangle, which is kind of weird. There's actually more. You're going to see that again in a second. What's the cross section? It's a hexagon. This is a hexagonal prism. Because you're slicing parallel to base, it's going to be a hexagon. What shape does this make in its cross section? It's a triangle. See it right here. If you slice a cylinder vertically, what shape does it give you? A rectangle. You see it right here. Huh. How about on June 1st? Definitely. You slice the cone horizontally and what do you get? Circle. You slice the sphere through the center of any kind and you get a circle. And last one, this one is a little weird. This is a cube that's been sliced kind of diagonally but not perfectly. And it gives you a trapezoid. It's not a triangle. Okay, last thing is rotations. And if you end up taking calculus someday, you're going to have to do this quite a bit. If you don't take calculus, then it's still just kind of cool. You can take a two-dimensional figure and rotate it around an axis, and it'll get you a three-dimensional figure every time. So this is formed by rotating rotating a two-dimensional figure around an axis. The axis of revolution is the line around which the shape is rotated to create a solid. So if you take a rectangle, for instance, and you turn it around an axis, it'll give you a cylinder because you're tracing that all the way around. We're going to do two examples, and I'm going to show you a video that will help actually see it. Okay, would you look at these last two? If you take a triangle and you turn it around all the way around that axis, what will it make? It'll make a cone. This point goes all the way around. Whoa. And it makes a cone. A cone with a radius of 3 and a height of 4.
What sorcery is this? AJ, I drew a cone.
Okay, if you take a rectangle and you rotate it all the way around 360, what will it make? It'll make a cylinder.
That is crazy.
Cylinder with a radius of 6 and a height of 8.
Do we need to put that?
No, I mean you can see it in the picture.